So number 4 says, use your earlier work to express the exact area under the curve of f of x equals x squared from 0 to 3 as a limit of finite sums. So to get the exact area, we say, well, the limit as n goes to infinity of the estimate area in terms of n. So that's going to be the limit as n goes to infinity. And our answer, when we did this problem, our x squared from 0 to 3, was this right here. So this is the function I want to take the limit of. So this is going to give me the exact area under the curve. So part B says, well, now evaluate this limit. So in order to evaluate this limit, I'm going to have to do a little bit of work here. So I'm going to pull the 9/2 out front. And I'm going to actually multiply this out. So I'm going to get 2n squared plus n plus 2n, so plus 3n plus 1, all over n squared. So I know that this limit should come out to be 2, but I actually have to show my work. So this is actually an infinity over infinity situation, so I can use L'Hopital's rule. So using L'Hopital, I can say, well, this is the same thing as 9/2 times the limit of 4n plus 3 over 2n. I'm still in an infinity over situation, so I can use L'Hopital again. Oops, I'm writing x here. This should say n. My bad. Right, I'm just going to leave the 9/2 here because I didn't write it out front. And now when I take the derivative, I get 4 over 2. So now I have 9/2 times 2, which is just 9. And the other way you can think about it is 2 times 2 is 4, and that actually cancels the 4. For 5, we want to do the same thing with our answer from number 3. So the limit as n goes to infinity of the estimated area, and our formula we got for this was 25n times n plus 1 over n squared minus 50 over n plus 25. So now they want us to evaluate this limit. So just like I did before, I'm going to actually expand this out. So this is 25n squared plus 25n over n squared. And then I'm going to say minus the limit as n goes to infinity, because I can distribute the limit across, of 50 over n plus the limit as n goes to infinity of 25. So the reason I'm doing this is because this is a L'Hopital situation, but the rest of this is not. So you can evaluate part of a limit if you can separate out all your limits. So for this guy, I can use L'Hopital, and I can say, well, I have the limit as n goes to infinity of 50n plus 25 over 2n, but the limit of this as we go to infinity is 0. So this whole limit is 0. The limit of 25 is just 25. So I'm going to need to use L'Hopital one more time because I'm still in an infinity over infinity situation. So this is the limit as n goes to infinity of 50 over 2 plus 25, and 50 over 2 is 25. 25 over 25 is 50.